Solve the square root of x minus 1 plus 3 equals x. Again, I'm going to rewrite the equation over here so we have a little bit more room to work with it. And already we can see that this is a more complicated equation than the ones that we've been working with before. One major difference is that on the left-hand side, we don't just have the square root of something, but there's an additional term. And if we want to use the same strategies as we did in the previous problems to get rid of that radical, the very first thing we have to do is we have to get that radical alone on one side of the equation. So we need to get rid of this 3, and we're going to do that by subtracting 3 on both sides of the equation. This leaves us with the square root of x minus 1 on the left, and on the right it gives us x minus 3. This is a general rule when we are solving equations with radicals in them. If it doesn't already start with the radical isolated on one side, we need to isolate the radical on one side of the equation before we square both sides or cube both sides, etc. So always, first, we must isolate the radical on one side of the equation. So we can't start in this problem by squaring both sides, because on the left-hand side, we don't just have that radical, there's extra terms, and so we need to get rid of those before we square both sides. Now that we have the radical isolated on the left-hand side, we can get rid of it by squaring both sides. So we need to square the left-hand side and the right-hand side. When we square the left-hand side, we're just left with x minus 1, because the square root and the exponent of 2 cancel each other out. Then on the right-hand side, x minus 3 squared just means x minus 3 times x minus 3. And if we want to expand the right-hand side, we're going to have to FOIL that out. So the left-hand side is going to stay x minus 1. And then on the right-hand side, when we multiply the first terms, we get x squared. The outer terms give us negative 3x. The inner terms also give us negative 3x. And the last terms give us positive 9, because a negative times a negative gives us a positive. Next, we're going to combine like terms on the right-hand side. So that's going to give us x squared minus 6x plus 9. And here we have a polynomial equation. Anytime we have an equation with an x squared or an x cubed in it, we need to get all the terms on the same side so that we can factor and use the zero factor property to solve. So we need to subtract x from both sides, and we need to add 1 on both sides so that we can get all of those terms on the right-hand side and leave the left-hand side equal to 0. So when we do this, we have x squared minus 7x plus 10 on the right-hand side. And we can factor this using the unfoiling method. We need two numbers that have a product of 10 and a sum of negative 7. Those are going to be negative 2 and negative 5. So we have 0 equals x minus 2 times x minus 5. Now we can use the zero factor property. So we set each of those factors equal to 0. X minus 2 equals 0, or x minus 5 equals 0. And when we solve these resulting equations, we end up with x equals 2 for the first one, or x equals 5 for the second one. So there are two potential solutions here, and we need to check both of them to see if either of them is extraneous. So let's start by checking x equals 2, and we're always going to check these in the original equation. So if we plug in 2 for x, this gives us the square root of 2 minus 1 plus 3 equals 2. Well, 2 minus 1 is 1, and the square root of 1 is just 1. So this becomes 1 plus 3 equals 2. However, 1 plus 3 is 4, and we know that 4 is not equal to 2. So what that means is that that's not a real solution. It's an extraneous solution. So we throw away x equals 2. Now we need to check x equals 5. If we substitute 5 into the original equation, we have the square root of 5 minus 1 plus 3 equals 5. Now 5 minus 1 is 4, and the square root of 4 is 2, so that becomes 2 plus 3 equals 5. And we know that that is true. This means that x equals 5 is an actual solution, and because we've thrown out x equals 2, x equals 5 is the only solution, and so our final answer for this problem is x equals 5.